Hello and welcome to Cruising Through Calculus. My name is Alex and today we're going to be doing a review of logarithms. The reason why we're doing this review is because in calculus you're going to be using logarithms at some point, and they especially come into play when you deal with logarithmic differentiation. So let's step right in and start with the first thing you need to know, which is how to convert between an exponential and a logarithm. So let's say you have something like this. Some number to the power of x equals some other number. Well, if you're going to convert that into a logarithm, what you're going to get is the log base b of m equals x. You can also do the same in reverse here. So let's go over a quick example of each of these. Let's say we have 2 to the x equals 16, and I want to convert that into a logarithm. Well, when I convert it, that's going to turn into the log base 2 of 16 is equal to x. Let's say that I start with a logarithm instead, like let's say the log base 3 of x is equal to 4. Well, if I convert that back into an exponential, that's going to be 3 to the power of 4 is equal to x. Now I'm going through this part pretty quickly because these particular kinds of things don't come up super often in calculus, but the next couple of things really come up often, so pay close attention to here. The first thing we're going to look at is called the product property for logarithms. So if you have a log and you're multiplying on the inside, you can actually split this up into two pieces that are being added, like this. So let's take a look at a quick example here. Let's say that we have the log base 2 of 3x. Well, using this formula up here, I can break this up into the log base 2 of 3 plus the log base 2 of x, since we're multiplying the 3 and x together. Our next property is called the quotient property for logarithms. It says that if you're dividing two things inside of a logarithm, you can take them and split them up and subtract them, like this. So let's do a quick example. Let's say we have the log base 5 of 16 over x. Well, we can split this up. We can do the log base 5 of 16 minus the log base 5 of x, just like that. Our last property is the power property for logarithms. So let's say you have a logarithm and then inside is an exponential like this, m to the power of n. You can actually take that n and bring it outside in front of the logarithm like this and multiply the two. So as a quick example, let's say we have the log of x to the fourth here. Well, I have x to the fourth, so I can take that 4 and I can pull it down in front of the log like this. One last thing I'd like to quickly go over is the difference between natural log and log. Now, I think that most people think of these as two separate things, and perhaps in one sense they are, but I don't think you should think of them as two separate things. I think you should think of them as both the same thing. That is to say, they're both logarithms. The difference between these two is that natural log here uses base e, whereas log, at least without anything written down here, is base 10. So technically speaking, I could write this here, log base e of x, and that's actually exactly the same thing as just ln of x, like this. And then let's not also forget that e is a very special number. Just like pi is a special number, you should think of e as a non-repeating decimal that goes on forever. Believe it or not, just those basics will get you through a huge portion of logarithmic differentiation and other log and exponential problems in calculus. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.